So today we're building a voltage-controlled amplifier, a weirdly fancy name for something that's just a volume controller. Because it's modular though, we can control the volume with the output of the other modules, like the random control voltage module we made last time, or something like an envelope generator to make a note sound. We can also use this as a utility for control voltage, or if you're feeling particularly spicy, you can use it as an awful ring modulator. I think. I'm not really sure what ring modulators do, but I think it's this. Anyways, let's get started on this circuit. Our microcontroller has 7 different analog channels, so we can put up to 7 different inputs and outputs through this module. That's enough for 2 separate VCA channels. We use 2 signal and 2 CV inputs each, and then 2 outputs, adding up to 6. And then our last analog channel goes to a knob to control the global max volume. I put this in as an extra utility to do stuff like fixed voltages and scaled CV really easily. Now onto the wiring of the breadboard. It's an utter mess this time, but it boils down to be pretty simple. Mostly just a wire from the analog pin to our component, then back to ground. The main thing to note here in this schematic is that our signal and CV inputs have the default pin set to high, or 3.3 volts. The default pin is the signal that we send to the microcontroller when nothing is plugged into the jack. We want it high here so that when nothing is plugged in, we can generate fixed voltages with the global maximum control. It's a nice little extra utility, basically for free here. And with the breadboarding finished up, we can move on to the code. Our Python code today is really easy. No confusing charts or weird math stuff at all. We can start by calculating our global adjustment by dividing our analog pin input by its maximum value, to scale it to a range of 0 to 1. Then we do that same scaling independently to the left and right channels, and then just multiply everything together. And with that, we're done with the code. It seemed too easy, and I feel like it's going to break in some unforeseen and terrible way, but regardless, let's test it out. And here we go. There's a difference in volume level controlled by our random output module. This was too easy. I'm starting to get nervous about it. What is success without struggle? Triumph without defeat? Glory without hardship? Can things just be unequivocally good and not need a deeper journey where some hard-won truth is uncovered? What are the boxes and wires really? Why do I care so deeply about the buzzing noises they make? Am I truly capable of It's time to stop getting existential and move on to the perf board. We have a nice little color-coded wiring scheme today, with red as 3.3 volts, black as ground, green is analog output, and blue is analog input. I could have done with more prior planning of how I was going to route the wires to avoid the absolute mess you see around the microcontroller analog pins, but it passes my quality check of technically working, so we can move along. Even though once it's inside the box, no one will ever be able to see these wires, I want to make them look pretty. Something to work on next time, I guess. It's a good thing I have like 80 more modules to build. Measuring where to cut holes in our enclosure is a weirdly tough problem. This time I tried out the strategy of replicating the positions of the jacks on a separate breadboard, then using an eyeliner pencil to transfer some smudges to the right place on the lid of the box. I don't hate this strategy, but the breadboard shifted a little bit while I was doing this, so the result is a bit off. Off the top of my head, I can't come up with a better way though, so I'll keep doing this one for now. I have a newfound confidence with the drill today. Focused, determined. I've become an expert in putting small holes in aluminum. Just give me a piece of aluminum, I'll put a hole in it. The big change here is really just that I got a backing piece of aluminum that's helping me out so I don't fling the box across the room when the drill catches onto the hole I'm drilling. No more flinging the box around the room and almost losing my finger. Moving up in the world. And once again we found ourselves in painting time. Our color today is this nice dark green. The nail polish I'm using to do this is pretty old, so it's going to take some finesse to get a clean finish on it. The process is really similar to the process of painting your nails. If your nails were the box for a synth module, then it would be almost exactly the same. And with that done, we just need to assemble the finished product. Please ignore how much more scratched up it is now. I had trouble cutting the hole for the USB to fit in off camera, and as a result, the module has a bit more texture now. Anyways, we can set up a simple patch with the modules that we have so far. Start by patching our wavetable oscillator into our new VCA signal input. Then VCA output to our aux out module, which should pass our signal forward and out through the speaker. And now we can control the volume of our signal with the smooth random module output. And a little bonus configuration here, we can use the VCA to scale down our smooth random output to a smaller range. Then use that to control the wave shape on our wavetable oscillator, so we're only modulating through a smaller subset of our wavetable, instead of the whole thing. And that's the module. Thanks for coming along on the journey, and I'll see you next time.